Hi, everyone. Thank you for coming and welcome to the Open Measurement Gathering. My name is Anna Ablove, and I'm part of the Censored Planet team and currently a PhD candidate at the University of Michigan. On behalf of Censored Planet, IOTA, MLab, and UNI, thank you for taking the time to join us. Over the next few hours, each project will deliver a 30-minute presentation highlighting recent progress, upcoming initiatives, and avenues for collaboration, followed by an open Q&A session. We invite you to submit questions in the chat or via the Q&A feature at any point today and fully engage with our conversations. With that, let us begin. Our first presentation comes from us at Censored Planet. Armin, take it away.
Great. Thanks, Anna. I hope you guys can hear me fine. I think that is a yes.
Yes.
Cool. All right. Yeah. So yeah, I'm happy to share the progress that our team, Censored Planet, did over the last few months. And yeah, excited to share it with the community. In terms of agenda, what we want to talk about in our presentation are 4 key points. The first one would be to discuss our new analysis pipeline, then also discuss our first API to allow users to fetch our data directly from our database, and then also showcase the new dashboard that we created. And then finally, just outline some things to keep an eye on in the coming months that we want to work on and publish. So yeah, I guess without further ado, let's jump into the new analysis pipeline. So I'll try to give a bit of background. So I joined the lab in 2021, and around that time, this was actually the first project that I worked on. We collaborated with Google Jigsaw and Google in general, who were always very generous with their support in our cause. They helped us with credits and support, whatever we needed. And back then, we basically just published our raw results into a Google storage bucket. And basically, any researcher or organization that would want to dig into our data would need to fetch the entire data set from the storage bucket and do apply analysis script that we published just to extract useful information out of it. But back then, Google Jigsaw reached out to us to help us to build the first analysis pipeline fully in the Google Cloud environment. And yeah, it worked out great, so to say. We used Apache Beam back then as the core logic behind it on processing our raw data set, the entire analysis pipeline. In the morning, we would fetch the latest results from the Google storage bucket, process it, and then dump the results into the BigQuery database, also in the Google Cloud. And the dashboard was built using Locker Studio to visualize our findings. And yeah, we put a lot of work in it together with Google Jigsaw, and we're super happy back in 2023, I think it was, to finally publish the dashboard, and we got great feedback on it. But it was just I guess, a couple of months later, a year max, where there was an incident happening. It was exactly in the week where the team was traveling to Berlin to attend the conference there, when we got the news that, there was an incident over the weekend, and Google reached out to us telling us, yo, what the F happened? You guys raised a ton of costs. And it turned out a researcher who was also interested in our data, but since we didn't have an API back then, just scraped the data from the dashboard. And the issue there was the scraper was built to hit the BigQuery database daily. So it started scraping the data from 2023, I think way back till 2018. So constantly hitting our backend and causing a huge bill, which I guess left us in shambles, so to say. We drained our Google credits that we generously got from Google. We were left with a huge bill. And yeah, we had to turn off the pipeline and the dashboard for now. And the aftermath of the whole incident was basically we had to, first of all, we weren't aware that there wasn't any bot detection running in Locker Studio. And second of all, we didn't consider these scraping attempts. So we never put like a hard limit on the API usage of BigQuery, which, yeah, caused us this trouble in the first place. Yeah, and after that incident, we of course had to scale back our efforts. Basically, we had to put on this daily usage limit for the BigQuery, which also meant that the dashboard often like rendered useless, so to say, because some users would like play around with the dashboard for a few queries, but as soon as the daily limit was hit, nobody else could use the dashboard for the day until the 24 hours were over and the usage quota reset. And yeah, and another measurement we had to take was to reduce the amount of data we were able to query through the dashboard. So we trimmed it down to 6 months and not our complete historical data. And also, because of the drainage of our Google Cloud credits, we also had to switch the bucket option to request a pace, meaning anyone who wants to download the data from a Google storage bucket would ultimately be billed for the download. And yeah, like again, I can't stress it enough how supportive Google was during the time. They scrapped the bill, they still gave us some credits, but we knew like thinking further into the future, it's just not sustainable to have like that dashboard running with the BigQuery backend in the Google Cloud, just because we would still have to enforce the quota limit just to avoid instances like that in the future. So that was the main motivation behind like scrapping everything, so to say, and build our own analysis pipeline. And so I'll just give a brief overview of how we approached it. So we basically already had 5 machines that were dedicated to run our measurements. We had 4 machines running Hyperquake measurements, 2 each for HTTP or HTTP protocol measurements, and the other ones for Discord and Echo protocol measurements, and 1 machine that would run our satellite or aka DNS measurements twice a week. The Hyperquake ones would split the workload into 2 batches, so they would run in total like 4 times a week just to catch all the data we wanted to measure. And our thinking was, okay, how should we approach this? So we have like already some machines that we use for measurements. Of course, like we're a small research team, so our resources are also kind of limited on what we can do. The benefit of the Google Cloud approach was we can scale basically infinitely. So yeah, we basically never hit any roadblocks, so to say. So with that thinking, we just needed a more, I guess, efficient approach and something that is sustainable to run in-house. And ultimately, we decided to use Apache Spark, which is basically just a framework that allows like distributed data processing. So we would use our existing machines that we already use for our measurements and just up the CPU core and memory resources there. And we would set up an Hadoop distributed file system, just basically allowing these machines to have a united file system where they can write their measurements to. And also, like once the measurements are done, we also uploaded still our data to the Google Cloud buckets. So we basically still have our backups in the Google Cloud storage, and basically still run a lot of services within the Google Cloud. But when it comes to the pipeline, the API, and the dashboard, this is now all hosted in-house, so to say. And additionally, we also used Data Fusion Comment, which is basically just an accelerator for Spark that just boosts the performance from the Spark framework. We then used Prefect for orchestrating all of our data processing runs, and ultimately decided to use ClickHouse as our replacement for BigQuery and Observable as our framework for the new dashboard, which we'll get to in a second. And I guess just in a nutshell, I'll try to explain how exactly we analyze our data. So when it comes to Hyperquake, these are like the elementary steps we do. We first unnest the data, since each server that we test for our measurements might hit like an error. So we try the measurements for a specific domain and a specific server for up to 4 times. So we basically unnest all of those measurements. Then we do some metadata enrichment where we basically just add IP metadata, geolocation data. And in the next step, we do signature matching, which basically just means we have a bunch of signatures that we look for to detect block pages. So in case that we actually detect a block page, this is most certainly an indicator for censorship. And after that, we also add for each domain a domain category, which we predefined. And the next step, the certificate parsing, is basically just limited to HTTPS measurements. All the other protocols can skip that when it comes to Hyperquack. And lastly, we do some outcome classifications where we, based on the errors that we receive and other metadata information from these connection attempts, we try to determine, okay, what are strong indicators for censorship triggers and what are like less likely censorship events and just configuration errors. Yeah, and the satellite approach is pretty similar, but still a bit different. So satellite basically has two batches that it produces. The first one are resolver results, where we basically query the DNS resolvers that we want to test. Therefore, we basically catch like any errors that the DNS query might return, other errors that we might capture during that process. And of course, we capture all the IPs that it answered with for a particular domain. So the resolver results similarly get unnested, enriched with metadata, just like Hyperquack. Added, we add the domain categories there as well. And the second batch is basically all the pages that we fetched. So every IP address that we got returned, we then also basically fetch the full page and also certificate data. So we do, again, like parse the certificate, get like all the metadata out of it, see if it's a valid CA or anything else unusual we can find there. We enrich it again with metadata, perform our signature matching, again, just to check are there any block pages being returned. And at the end, we basically union those data frames together. This is, in our current pipeline, basically the most heavy step because it's a wide transformation. So we need to shuffle a lot of data around between each executor. But yeah, I guess in a nutshell, this is just the steps we take to analyze our raw data before we dump it in our new ClickHouse database. Yeah. And when it comes to results, what we found is, especially for smaller batches, so in this case, HTTP, Discord, and Echo, one daily batch takes us about 1.2 minutes to process, which compared to our previous approach, using data flow in the Google Cloud, is up to 20 times faster. But we also see that the gap decreases by the amount of data we basically input. So the HTTPS data is a bit larger. We also do certificate parsing in that context. So we see we're still faster there, but the improvement gets lower and lower. And the DNS data, which is like the largest data set we need to process, we still end up like around 10 minutes for one data batch compared to the, I guess, 90 minutes we needed before. So we still ended up faster as in the previous approach, but that is because we hit like kind of the sweet spot for our setup. That being said, like Google BigQuery shines with, I guess, like terabytes of data processing. So if we would run like a full backfill using the Google Cloud environment, we would be able to backfill our entire historical data within 1 day. Compared to our current pipeline, if we would do that, it would take us probably 2 to 3 days. So like I said, like for daily batch data, we end up being faster. We also are able to trigger the pipeline immediately after the measurements were done. So before we would like run the pipeline once a night. So you would see updates once a day. Now, as soon as the scan is finished, we trigger the pipeline and we dump the results into our ClickHouse table, and you will see it immediately after in our new dashboard. So yeah, like I said, I'm not trying to talk shit about Google Cloud here. They're still like more performant because they can just scale up infinitely when it comes to bigger data batches. But for our use case, it turned out Spark did a great job there. Yeah, so I guess that was just a short excursion of how we do our analysis and how our new pipeline basically is set up. And now I'm excited to announce that we finally also have our own Censored Planet API. That one was also a vision that we had for years. We actually initially started to create the first API using the BigQuery backend. But since due to the incident, we knew, okay, this won't be sustainable for us. So therefore, we switched to our own approach. Therefore, we use GraphQL as our interface for the backend, the ClickHouse database backend. And I guess I'll just show you a quick showcase on how the dashboard works, the API works. So if you go to datacensoredplanet.org, you will be greeted with a graphical interface of our API, of a GraphQL API. And you can look up here in the docs section which query endpoints we actually provide. Currently, it's still a bit limited, but we will continue improving that as well, add some more interesting endpoints that users would want to use or enjoy. So right now, you can basically fetch our Hyperquack data, satellite data, and the dashboard data that is being displayed on the new dashboard, plus like some additional endpoints that just give you some metadata and ideas on what to query. So I guess for a start, let's say you're just interested to know which countries do we actually cover for a certain date range. So you could use the countries query here. Just real quick, the first keyword is just to use query, and then you can name it whatever you want, just countries test, for example. And the next step is basically to define the endpoint, which is in this case named countries. So we just take countries and we define our filter. We need to give this endpoint basically a date range. So we say, okay, for what date range do I want to see which countries we actually cover? So we can say start date 2025 and an end date. Let's take 2 months for now, 28. And that's pretty much it. Oh, yeah, we need to specify the protocol we are actually interested in. So I think I have some here. So we just say protocol, and let's say we want to know for the HTTPS protocol which countries do we actually cover for this date range. So if you just hit the play button, you will see all the country codes that we have data available for this particular protocol. So now you know which countries you can actually query. The next thing you might want to be interested in is to find out which domains did we actually test for the same date range. I'll just copy that query right here. So this time we hit the endpoint, the resolver endpoint called domains. We can just copy and paste the same date range here. And the same protocol. And if we now say domains, it will still the full list of domains that we tested. It's slightly above 2,000. So you can just pick any of those domains to test to fetch the data from Hyperquack or satellite. So let's just do that real quick as well. So let's say you want to query the Hyperquack data. Again, you can choose for Hyperquack 1 out of 4 protocols. So it would be HTTP, HTTPS, Echo, and Discard. You could pick any domain here. Let's take this one, put it here. Let's just keep that country for now and hit Hyper. And therefore, you can basically fetch the data points that you want. And the sweet thing about GraphQL is it prevents overfetching, which means you can basically define here which fields you're actually interested in. Because you can go into the Hyperquack definition and see all the available fields. So you can exactly determine, okay, which fields do I actually want, which ones am I interested in. Let's say you also want to know which server ASN this particular batch resolves to. So you just hit again the endpoint, and then you will also get the exact results that you were looking for. Apart from that, like I said, you can now just automatically fetch all the Hyperquack satellite and dashboard data. We have some additional metadata information here. It's mostly used for a new dashboard, but if you want to play around with it, and like I said, we're happy to hear any feedback. Like if you think like there's particular endpoints that we should add, we'll definitely would want to hear from you. For now, it's like a bit of a limited list, but we'll add continuously new endpoints there to query. Yeah, I think that's pretty much it. In case you want to do it programmatically, you still hit the same endpoint. It's just, in this case, /query. And then as well, you just define the domain you want to query, the protocol, which endpoint, in this case, again, hyperquack, the date range, and then you decide again, okay, which data fields am I actually interested in? So when you execute it, you'll get all the data you want from us. There's currently a slight limitation there. We allow data fetches for these endpoints for, I think, like one request up to 3 months. It's just like some limitations that we were playing around with. We might adjust it later on, like to allow even more data fetches for one request. But like I said, you can just build your own script and fetch it with subsequent queries to get all the data you want. Yeah, and that basically just covers a quick demo of our new API. Following it up with our new dashboard, which we are also excited to announce, which now runs in-house and uses the ClickHouse database. So in this case, we'll just go to dashboard, Censored Planet. Yeah, and you will be greeted with this welcoming screen. So it basically gives you an overview of how many measurements we currently have in our database. We're still in the process of backfilling all the historical data. For now, it's like exactly like 1 year worth of data that we have for all of the 5 protocols we serve, which covers right now 210 countries. And for the last 30 days, we basically ran, about 1 billion measurements. And yeah, funny enough, during the last OMG meeting, I had a coffee together with Maria and Arturo from Uni, and we were just like a bit spitting ideas on what to improve and what to work on in the future. And I think it was Maria that mentioned it would be cool to have like a globe to display like all the data captures we had. And I guess that was the initial idea, to just build this little toy globe to see, based on our data, where we see the most interferences in the last 30 days. But I have to, you basically have to take it with a grain of salt. For example, you will see that Iran and Turkmenistan have the highest interferences that we detected. This is not specifically like censorship. It just means like signs of censorship that we detected. When you dig deeper into our data, you will see, okay, which indicators are stronger for censorship and which not. And specifically for smaller countries, or countries where we don't have that many endpoints, like Iran or Turkmenistan in this case, you should take that data with a grain of salt, because we only have a limited amount of endpoints we can test in these regions. And if it happens to be like one endpoint and it is like very restrictive, then you will see exactly this this map, this output. And if you want to dig deeper in our data, you just hit the link here. And the structure is pretty similar to the previous dashboard we have, the landing page. So you can choose your country here, the data protocol you want to query, the date range. Currently, you can query up to 6 months at once for up to 10 domains. And yeah, similar like the old dashboard, we had a pivot table. This is like a more simpler table, but you can basically just filter the results you're interested in. Let's say you want to see all the results from the TimeWeb network in Russia. So you just hit TimeWeb. And if you're interested in only one protocol to be displayed, you can see like bbc.com. For this particular one, you see like, okay, we couldn't detect any interferences for this domain and this specific network. But overall, if you go further down, you see the outcome timeline that will give you, like, for this specific date range, okay, a summary of how many interferences or non-interferences did we capture. So in green, the match just means, okay, there was no interference detected. For like red sections, it basically means, okay, there is definitely something going on. We found like some either like TCP resets or timeouts that clearly indicate that on the path to that server endpoint in Russia, in this case, there was a DPI that terminated our connection, in this case for HTTPS. If you scroll further down, you will see a summary of the outcomes per network. You basically can just click into it and then see, okay, which subnetworks, what are the aggregated results for each subnetwork. If you click outside, you go back to the previous view. And we also added like a little playful summary. It's basically a sunburst graph. It will show you like the breakdown of how the coverage was exactly for this exact query that you sent. In this case, like 28% of our measurements went to this exact network. Then you can also choose a specific subnetwork. In this case, this ASN network, and then you can also get displayed which categories these domains belong to. The outer circle then tells you which domain exactly it was, and then the outcome as well. And it just breaks you down in percentage. Okay, what is the exact breakdown of our measurements here so far? Yes, so that was basically just a quick overview of our dashboard. I don't think I have much time left, so I'll just hurry up here a bit. Things to come, so just things to that we want to specifically work on and focus on more in the future. One big thing is like our rapid response efforts. In the past, we did a lot of I guess like digging on just events that were popping up and just like scrambled the team together and said, okay, let's focus on this all together. Back then, we did a lot of rapid response use cases in Russia when it came to the throttling of Twitter or the network responses we saw to the invasion of Ukraine, or also the HTTPS interception in Kazakhstan. So these are some efforts that we definitely want to focus on more. And if you're an organization or a researcher that wants to collaborate on these efforts specifically, please feel free to reach out to us. We're also currently like automating our whole rapid response setup so that we can spin up like these measurements like as quick as possible if we need them. So yeah, if you're interested in collaborating, just let us know. Another cool thing that we're planning to publish soon as well is our Censored Planet alert system. And again, thanks to Google, who gave us access to the Google Trends API, which basically allows us like to daily query the data set. And what we're specifically looking for are like searches for the keyword VPN, since we noticed that people that are like in censored countries or that experience censorship maybe for the first time, the first instinct is like to just Google and see what's happening, and then at some point maybe, okay, what can I do about it? A lot of people just I think the first thing that pops into their mind when it comes to circumventing censorship is to look for VPN keywords. At least that's what we've seen in most of the countries. And so basically by just observing like the spikes in searches for the VPN keyword, we were actually able to detect, okay, like censorship events that are happening almost like in real time. So this is basically just a mock-up what the new dashboard will look like. It will also be published on our dashboard website, and it will give you an overview where these spikes happen. So we'll also display an impact factor. This is the red area underneath the graph. We will just highlight like how impactful was the spike, like how abnormal was it. And the higher the spike, the more attention it should seek, like and get this specific event, which indicates there's a new censorship event going on in a specific country. Once we actually clarified what was happening in the country, you will also get like detailed information on exactly what was going on that day. And yeah, it's like a super cool project that we're also looking forward to publish soon. But wait, there's more. We're also excited to announce our new Censored Planet website. Finally, after so many years and planning around it, we finally got around to polish up our website. Thanks to, most importantly, also to Shabir, our new addition to our team, who put a lot of effort in like just programming our new vision. And I guess at this point, I also want to say thanks to Professor Enzafi and the whole team for putting so much effort into the last few months to pull through and finishing up all these projects that we wanted to have, especially the website and the pipeline and so on. So we're really excited to share all of this with the community. I hope you dig it as well as we do. Yeah, give it a shot. Go to censoredplanet.org. Just browse through the website. It now better encapsulates all the different research projects that we work on. It's not just the observatory. We do a lot of research in traffic analysis, traffic fingerprinting, VPN research, and so on. So go check that out. And again, yeah, if you have any feedback, if you feedback about the dashboard, the API, or anything else, please reach out to us at censoredplanet@umich.edu. And with that, thanks for your attention.
Yeah, thank you, Armin, for the talk. My name is Aaron. I'm also a PhD student with the Censored Planet Lab. At this time, the next 12 minutes or so are allotted for questions. And for those that have questions, please put them either in the Q&A or the chat. Or if you would like to speak your question, please raise your hand and I can enable you to talk. So at this time, I'll start with questions regarding the Censored Planet dashboard itself. So Armin, can you give us a sense of how much data does Censored Planet process? And can you give details about like per protocol, how much data that is?
Yeah, sure. So I guess like the smaller data sets are around the protocols like HTTP, echo, and discard. I guess like one batch of measurements would contain, I guess like roughly 1 to maximum 10 millions of measurements. When it comes to HTTPS, like the data set usually grows a bit larger, but it can fluctuate depending on, because like the selection process of which endpoint to query will always like be kind of randomized. So we try to switch it up as often as possible. So the amount of data can actually vary, but the largest data set that we have or that we need to process is the DNS one that can get up to, I guess, like 60 million rows. Yeah, it was a pain point at first just to process it, to set it all up for the DNS one, but it's still manageable.
And this is a two-part question. Is our API rate limited? And then additionally, is the same list of URLs tested for any country requested, or does the URL list differ per country?
Yeah, so regarding the URL lists, so it doesn't differentiate between countries. So basically the same test list has been tested across all endpoints, so all countries. And regarding the API, we currently do have a rate limit, which is not that hard, I would say. We can adjust it as well, like given based on the user feedback that we get. But right now you can send like 20 requests per second from the same IP address. Like I said, it's the first time we're still like trying to figure out what the correct rate limit would be, just to be on the safe side, but we will steadily increase the amount that people can actually query as we go.
I'm going to enable the participant raising their hand to talk for their question at this time.
Okay.
You can.
Hello. Can you hear us okay?
Yep.
Yeah.
This is Ram from UC Santa Cruz. Hey guys,
Hey, Ram.
this is super cool to see. Thank you so much for all of the amazing work. I know how much we've been wanting to work on this dashboard, and Armin, the work that you've done with this API is so cool to see. It's been something that we've been wanting to do for a long time, so it's really, really, really nice to see. And I'm so glad it's out there for the community right now. So, I mean, one of the questions I wanted to ask is, do you ever foresee sort of adding the ability to, for the community to submit custom domains to test? Because that would be super cool to see.
Yeah. Thanks. First of all, thanks, Ram, for your kind words. Like I said, this is all built on top of your shoulders as well, because you were a big part of our team for so many years, inspiring us as well. So thanks for the kind words. And we're also super glad with the efforts we put in so far. And yeah, it's a good point, actually. We do want to like open up, I guess, our analysis approach more to the community. So one key aspect that you mentioned would be to allow like to add custom domains, as well as perhaps like the ability to spin up like custom measurements from the community. So that's also something that we've been discussing, to allow certain individuals that reach out to us to just allow them to have an API where they can just trigger these measurements directly, select the countries they want to and the domains they want to test, and just allow them to run these measurements. So yeah, definitely that's something we want to work further on, just to open up a bit more to participants out of the community.
Yeah, that would be great. Thank you so much. I'm here with my entire research group over here, and we're all super
Cool.
excited to continue working on this, and we'd love to keep digging into Censored Planet and see what we can do. Thank you so much.
Cool. Yeah, they can be glad to have such a nice professor. Thanks, Ram.
Looks like we have a couple questions regarding the Google Trends data. So first is, are the search term frequency measurements multilingual?
Yeah, I guess like Evan, if you want to answer that, I guess you're the most knowledgeable on it.
Yeah, I can answer those questions since I work on this project. So yes, the search term frequency measurements are multilingual. They also cover differences in spellings and abbreviations. So people typing out VPN versus spelled out virtual private network. And they also cover an aggregation of lots of searches related to VPN. So it doesn't matter what brand or implementation of VPN people are searching for. Those are also covered under the top. And someone also asked, to what extent is HTTPS Google search censored? That's also a good question. To our knowledge, China outright blocks Google search. I believe other countries also have partially or fully blocked Google search, at least temporarily in the past. We can't comment to the exact internals of how Google Trends works, since the process is not publicly disclosed, but Google Trends is robust to blocking to some extent. We have caught multiple instances of censorship that affected Google products, yet we're still able to see spikes in VPN searches. So Google Trends is still able to recognize searches from countries where Google is affected. And it looks like at this time, those are all of the questions that have been submitted so far.
Cool. All right. Thanks again, guys, for all the questions, and yeah, for your time.